Nicholas Copernicus was introduced to the world on February 19, 1473 in Torun, Poland. He was the youngest of his three siblings. Between 1491 and 1494, Copernicus studied astronomy, mathematics, philosophy, and sciences at the University of Krakow. In his final year at the university, Copernicus wrote his own observations on astronomy and mathematics. He left before completing his degree when he went back to Italy to study at the University of Bologna from 1496 to 1500 to study canon law. Copernicus was meant to spend 3 years in Italy studying the rules and laws of the Catholic Church. It was planned that he become a doctor of law, which will help him when he became a canon in Morbia. Instead, he wanted to study astronomy and mathematics. Learning Greek was important to Copernicus because many of the works he needed to understand for his astronomy were only available in Greek. In the end, Copernicus did not do enough work on his law course and did not graduate. During his time in Italy, Nicholas Copernicus formally became a well-paid canon of the Catholic Church in Warmia. Copernicus headed south again, this time to the Italian city of Padua. Once there, of course, he continued to study those things that he was most interested in, astronomy and mathematics. In addition to studying the things he was not meant to, he did actually do all the work that he was meant to. He studied medicine very successfully and also managed to pass his exams to qualify as a doctor of law. He returned to Warmia permanently in 1503 when he was 30 years old. During his time in Bologna, Copernicus had become friends with the experienced Italian astronomer Domenico Maria Novara. They had carried out many hours of observations of the night sky together, with Copernicus serving as an informal witness. Astronomers in those days worked with the naked eye. Galileo was the first person to look at the skies with a telescope, and he wasn't even born until Copernicus had been dead for over 20 years. An astronomer by the name of Claudius Ptolemy had everyone believing that the Earth was the center of the universe. At one point, saying that the Earth was not the center of the universe was considered an insult to Earth. You could have been hanged for saying or trying to prove that the Earth was not the center of the universe. Most of Ptolemy's work did not make sense. For example, his work stated that every month, the moon's distance from the Earth should change by a factor of 2. That would mean that every month, the moon would appear to change in size by a factor of 2, growing and then shrinking again. Nobody had ever seen this happen, so something had to be wrong. It turned out that the errors were actually present in Ptolemy's work. If Ptolemy could be wrong about something as simple as the moon's orbit, then maybe he'd been wrong about other stuff too. For example, he had said that the Earth was the center of the universe. Could that be wrong too? It was clear to Copernicus that there were some things wrong about Ptolemy's theories. One day maybe he could add some theories of his own. Back in Warmia in 1503, Copernicus worked on astronomy when he could, but he was usually busy with other things. By 1514, he had seen enough in the sky and thought enough about his observations in order to create a document called a little commentary to the people he trusted. In this handwritten document, he put forward his new view of the universe. He thought people should shift from a geocentric view to a heliocentric view. One of the main points in his document was that the Earth was not the center of the universe. The center of the universe is near the Sun. The other main point in his document is that the yearly cycle of the movement of the Sun is actually the Earth orbiting the Sun. Copernicus had revealed his new theory of the universe to a small number of trusted friends. He was not going to begin a scientific revolution doing that. By 1532, Copernicus had made all of the observations and applied all of the mathematics he needed to identify Earth's place in the universe. He had finished writing the first manuscript of his groundbreaking book, The Revolutions of the Celestial Spheres. He did not publish it, though, because he was worried about the reaction it would get. He showed it to close friends and associates, and word began to leak out that Copernicus had a theory that Earth and the planets orbit the Sun. The Pope heard about it, and archbishops heard about it, but at this stage, people just wanted to hear more about it. Nobody came after Copernicus to burn him at the stake. By 1539, 7 more years had passed and Copernicus had still not published it. This changed when Georg Joachim Rheticus, a German mathematician, came to learn everything he could from Copernicus. Rheticus studied with Copernicus for 2 years. He read the revolutions of the celestial spheres and was extremely enthusiastic about it. He thought Copernicus owed it to the world to publish it. Rheticus also helped Copernicus by bringing him new books about mathematics, which helped with Copernicus's final calculations for the movements of the heavenly bodies. Meanwhile, Copernicus allowed Rheticus to publish a book called The First Report, in which Rheticus gave a basic summary of Copernicus's heliocentric theory. Again, no one threatened to kill or harm Copernicus, so he gave the manuscript of his book to Rheticus to be printed in Germany. The printing turned out to be a source of great anger to Rheticus and Copernicus. The printing was supervised by Andreas Osiander, who added a note at the beginning of the book which stated that, even though the book's theory was unusual, if it helped people do astronomy calculations, it didn't matter if it wasn't really true. Although Rheticus and Copernicus were deeply unhappy with Osiander's note, there's every chance that the book was only allowed to be published freely because of it. Osiander had given the church an excuse not to condemn the book immediately as heretical. The book came off the printing presses shortly before Copernicus's death in 1543. Copernicus, diplomatically, had dedicated his book to the Pope. Another factor that saved the book from immediate suppression is that it was so mathematically difficult that only highly educated people could read it, most of whom were less likely to start ranting on street corners than others might have been. The general feeling among astronomers who read and understood all of Copernicus's book, the observations and the mathematics, was that this was the best book on astronomy for 1300 years. Copernicus's theory that the planets move around the sun in circular orbits removed a number of problems caused by Ptolemy's geocentric theory. In particular, Copernicus removed the need for an equant, a very awkward mathematical device required to make Ptolemy's geocentric theory work to any extent. With the benefit of hindsight, we can also see today that Copernicus's approach enabled him to be the first person to establish the correct ordering of the solar system's planets. Ptolemy had wrongly placed Earth closer to Mercury than Venus. Unfortunately, Copernicus's theory was not a perfect description of the planet's movement and position. Even though he was correct in saying that the planets orbit the sun, he was wrong in saying that they follow circular paths. This error led, like Ptolemy's system, to some awkward mathematical compromises, and so astronomers used Copernicus's methods where they found them helpful, but saw little need to abandon their basic views. Gradually, acceptance of Copernicus's heliocentric theory spread, and with it a scientific revolution, in the hands of Galileo and Johannes Kepler. Kepler, adding on to Copernicus's work, showed that the solar system is indeed heliocentric, but the planets follow an elliptical path, not a circular path. Unusually, disapproval of Copernicus united both Catholic and Protestant church leaders, although as time passed, Catholic disapproval increased, while Protestant disapproval decreased. As support for the truth of Copernicus's heliocentric theory began to grow stronger, the Catholic Church, detecting a threat to its supremacy, declared that the support for heliocentrism was contrary to the religion. In 1616, the Church banned Copernicus's book completely. In 1620, the Church approved Copernicus's book after editing it. Any sentences in which Copernicus wrote about a moving Earth and a central sun were removed or changed. Despite the final approval, the book was still not actually published in any countries with a powerful and strong Catholic Church. Nevertheless, support for Copernicus continued to grow, and his ideas triumphed over those of his opponents. It was a victory for the evidence-based science, interpreted using the language of nature, mathematics. Copernicus's contribution to the astronomical history was large, and it was a huge impact as well. He changed the way of thinking, not only astronomically but also religiously. This was because the Catholic teachings were based on the theory that the universe was Earth-centered. He also went against the theory that a Greek astronomer, Ptolemy, argued about, the theory that the Earth was a stationary sphere that was in the center of the universe and that the other planets, including the Sun, was orbiting around the Earth. This theory had been thought up of in 150 AD and had been used since then, making Copernicus's theory a very large impact. Even though Copernicus's theory mostly went up those two obstacles, many still had problems with this theory because if the Earth was orbiting and spinning, many thought that if one jumped up, then they would be left behind in that very spot, so the person would travel, which of course they knew did not happen. Even so, in the end, Copernicus's theory was correct.